Welcome to section 4.4. Today we are on page 17 of your notes packet, and our objectives today are to be able to use the fundamental counting principle, combinations and permutations to solve problems, okay? One of the big changes in general, all right, is that up until now in this chapter, all of our problems, our answers have been tiny, 0.001, 0.5678, something like that. All of our answers for probability, all of our answers have been between 0 and 1. All right. Today we're switching gears and it's going to be how many ways. If it's how many ways, our answer can be 1 to infinity. Okay, you can have huge answers. We're going to have 4,567 today. We're going to have all these different types of big answers. So, first problem. A sporting goods store offers 3 types of snowboards. Okay, all mountain, freestyle, and carving. And it offers 2 types of boots, soft and hybrid. How many choices does the store offer for snowboarding equipment? All right, so the first way we can handle this is we can handle it with a tree diagram. We have all mountain, freestyle, and carving. And then each of the boards, you can buy soft or hybrid boots, soft or hybrid boots, soft or hybrid boots. So our choices for mixing together a board and boots, we have 1, 2, 3, 4, 5, 6 ways. All right. Another way we can look at that is we can use the fundamental counting principle, which lets us say, all right, we've got 3 types of boards, and we're going to multiply that with the 2 types of boots, and we get 6 ways. All right. Now, visual learners really like the tree diagram. I'm a fan of just multiplying, particularly in situations like example 2, where a tree is just absolutely unrealistic. All right. Here I wrote the fundamental counting principle is used to count the number of ways a task can occur given a series of events. Basically, you multiply the number of possibilities each event of the task can occur. So, let's say you're framing a picture. The frames are available in 12 different styles. Each style is available in 55 different colors. And then you want a blue matte board, like the rectangle around the picture, between the picture and the frame, and that's available in 11 different shades of blue. So your tree would be 12 branches, and then off of each of those 12 you draw 55 branches, and off of each of those 55 you draw another 11. Literally impossible to do without messing up. So instead, you can just take 12, multiply it with 55, multiply it with 11, and you get 7,260 ways. All right, this concept is used for all kinds of stuff. So let's talk about license plates. All right, the standard configuration for a state's license plate is 1 letter. Remember, there are 26 letters, followed by 2 digits. There are 10 digits, 0 to 9 means there's 10 digits, followed by 3 more letters. So, how many possible different license plates are possible? I don't know why I wrote the word possible twice. If letters and digits can be repeated. So if we're allowed to repeat, and you have 26 choices for the first letter. Notice I put like placeholders here, and I just put letter, digit, digit, letter, letter, letter to help me stay organized. Then there are 10 digits, 26 letters, 26 letters, 26 letters. You're going to throw that in your calculator, and you are going to come up with 45,697,600 ways for plates. So for this state, if they have these as your choices, that's the total possible license plates that could be made. Now for part B, it says how many different license plates are possible if letters and digits cannot be repeated. So if you can't repeat, there are 26 choices for the first letter, 10 for the first digit, but then 9, then 26 counts down to 25, 24, and 23, which gives us 32,292,000 different plates. So if you think about how many cars there are, right? Think about New York, California, New Jersey even, right? So many cars. If they take away the ability to repeat, it drops by 13 million different license plates. So of course they're going to let repetitions happen because it's important. Now, let's talk about passwords. This is the big reason why they make your passwords all crazy now, right? You need to create a password for university login. It needs to be 8 characters long, so I drew 8 blanks. It can be uppercase, 26, lowercase, 26, digits 0 to 9, 10, or a symbol. And I gave you choices. So 1, 2, 3, 4, 5, 6 symbols. So if repetitions are allowed, how many possible passwords can be made? So what number goes in each of these spots, right? If you think about it, you can put this, 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 or this in each spot. So 26 plus 26 plus 10 plus 6, we got what? 52 plus 16 is 68, right? So we have 52, 60, yep, 68. There are 68 items that can be put here. There are 68 items here, and here, and here, and here, and here, and here, and here. So this is really 68 to the 8th power, which I don't know. What is that answer? Oh, epic. 4, 5, 7, 1, 6, 3, 2, 3, 9, 6, 5, 3, 3, 7, 6. Go backwards. So hundreds of thousands, millions, billions, trillions. There are 457 trillion different passwords if you include uppercase, lowercase, digits, and symbols. If you don't include like uppercase or lowercase, you would drop this from 68, you drop it down to 42. This answer would be so much smaller. Okay, which is why in your personal life, you want to use as complicated of a password as possible, including all of these layers, right? Because then it makes it that much more difficult for someone to hack into your password, okay? College, it's important that your password is secure. Your bank account, credit cards, anything finance, personal information, you want your account to be as secure as possible with the most secure password as possible. All right, so let's talk about factorials. All right, with factorial, you're gonna have an exclamation point. I'm actually gonna do these problems and then explain to you what the end part means. So 5 factorial is when you start with the number 5 and you multiply down till you get to the number 1. So 5 factorial will be 5 times 4 times 3 times 2 times 1. Okay, you can do it by hand or on your calculator. You can hit 5 and then there's 2 places you can locate it. One is if you hit menu and then probability, and then it should be right there, number 1, factorial. Okay, so see it goes 5 factorial. It just did 5 times 4 times 3 times 2 times 1, and you get 120. All right, 8 factorial would be 8 times 7, 6, 5, 4, 3, 2, 1. All right, test it out. Make sure you know how to get it in your calculator. You're going to get 40,320. The other place you can locate factorial is you can hit 8. And then down here where this question mark is, there's an exclamation. There's factorial. So you can pick factorial and press it there. 40,320, 40,320. All right, 11 factorial would be 11, 10, 9, 8, 7, 7, all the way down to 1. You would get 39,916, 800. Okay. 0 factorial is a trick. It's actually 1. All right, and it's just a mathematical trick. So what happens is n factorial is you take the number, then you do 1 less than the number, and you multiply that with 2 less than the original number, and you keep going all the way till you get 3 times 2 times 1. All right, that's the formal definition of n factorial. I'm not going to ask you for that, but that's what we just did here. Okay, so if we look at, I'm actually going to come back to this bobsled problem. Let's first talk about letters, all right, and how we can arrange letters in the word. So in how many ways means our answer is going to be large. Okay. Let's talk about the way we can rearrange the letters in the word cat. Now, for clarification, they don't need to form English language words like Webster's Dictionary. You can just rearrange them. So we have C-A-T, but we could also do C-T-A. All right, then you could start with A. So if you start with A, you can have A-T-C, or you could have A-C-T. You could start with T and get T-A-C or T-C-A. So starting with C, starting with A, starting with T. There are 6 ways. Well, we get 6 also by saying, hey, there are 3 letters in the word cat. 1, 2, 3. 3 factorial is 3 times 2 times 1, which is our 6. All right. Now, let's take a look at the word mom. Mom, if I flip-flop the M's, is it going to give me a different way of writing M-O-M? No, because the M's are identical. So I have M-O-M, I have O-M-M, or I have M-M-O. Okay, well, this has 3 letters, so why can't I use 3 factorial, right? This answer is only 3 ways. And what we do is we start with putting 3 factorial in the numerator because there are 3 letters in the word mom. But then in the denominator, we're going to have, there are 2 M's. So you put 2 factorial because there are 2 M's. All right. So in your calculator, you could do the fraction button. Okay, you could do control divide for a fraction. You could do 3 factorial over 2 factorial. And there you go, 3. This is 6 divided by 2 is 3. All right, so let's try a couple more. Let's try Miami. Miami is 1, 2, 3, 4, 5 letters. But there are 2 M's and there are 2 I's. So you're going to have 2 factorial in the denominator. Make sure you use the control divide. Do control divide 5 factorial over 2 factorial, 2 factorial. Make sure both 2 factorials are in the denominator. You see that? Like that. Okay, and then when you press enter, you get your answer, 30. Okay, banana. You have 1, 2, 3, 4, 5, 6 letters in banana. There are 3 A's and there are 2 N's. So it's going to be over 3 factorial, 2 factorial. Type this in your calculator. You should be getting 60. Okay, so now pause. Try Philadelphia and Tallahassee on your own. Okay. P2, H2, I2, L2, A2, right? So you're going to have 12 factorial over 1, 2, 3, 4, 5 factorials of 2, and that will give us 14, 9, 6, 8, 8, 0, 0. Okay, Tallahassee, you're going to have L2, A3, S2, E2. So you're going to have 11 factorial over 2 factorial, 3 factorial, 2 factorial, 2 factorial. Oh, by the way, you can't just multiply these together and then make it one big factorial. You have to do each one of their own as little factorials. All right, and this one should come up as 831600. Alrighty, so now let's go back to this bobsled problem. Okay, there are 10 teams competing in the final round of the Olympic 4-person bobsled competition. So in how many ways can the bobsledding teams finish the competition if we assume there are no ties? So if you think about it, we want all 10 teams. So we're going to have 10 spots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many choices are there for the first spot? How many teams can come in? There's 10 teams, right? And then once somebody wins first place, how many choices are there for the next? 9. And once somebody wins second place, now first and second have been awarded, so there's only 8 left for third, then 7, then 6, then 5, then 4, then 3, then 2, then 1. Okay, there's only, by the time the first 9 teams have finished, there's only 1 team who can come in last. So really, you could just have 10 factorial as your problem. And our answer would be 3,628,800 ways that those 10 teams could come in and the orders in which they could cross the finish line. Well, how about B? In how many different ways can 3 of the teams finish first, second, and third? I only want first, second, and third. I don't care about any of the others because they didn't win a medal. There are 10 teams to win first. There are 9 teams to win second. There are 8 teams to finish third. All of this doesn't matter because they didn't get a medal. I just want to do 10 times 9 times 8. And that would be 720. There are 3.6 million ways that all 10 teams can finish. Different orders. But there are only 720 orders for winning first, second, and third place. And this is an example of a permutation. Okay. One of our objectives was to deal with permutations and combinations. Permutations, order matters. Okay, you're arranging. They're going to be in rows. Okay, they're orders that happen. If things are put in order, we use this formula where it's NPR. There's a calculator shortcut. I'm going to show you guys kind of right away how to apply it. Okay, so with this, we've got NPR. Your bigger number is always on the left, and your smaller number is always on the right. If order doesn't matter, then we're going to use a combination, and I'm going to explain this as we're working through the problems. All right, in combinations, it's still bigger number on the left, smaller number on the right. You'll notice the numerators are the same. The denominators are both n minus r factorial, but then in a combination, r factorial goes in the bottom as well. Okay? I like to think of it as how many you have, permutation, how many you want. And these numbers are like little subscripts, like how in slope it's y1 minus y2, and there's subscripts at the bottom, same idea. So if we go back to this, all right, we had, for part A, we know the order matters because they're finishing in medals, right? So first, second, third place is order. We have 10. We want 10. Okay, how we get to permutation in the calculator is you can click menu, probability number 5, and then right there, permutations. Okay, and there's also combinations. So you can do permutation, and then you type in 10, comma is located right here next to the pi button, 10. 10 comma 10 would be this, 10 permutation 10. And when you press enter, there you go. This is this answer. All right, now if I want to do the next problem, how many teams do I have? 10. How many do I want? Just want the top 3. The calculator takes care of this idea for you. So permutations, you can use this notation or you can use these placeholders. Either way is fine. So I could do menu, probability, permutation, 10, comma, 3 for the second problem. There you go. There's my 720. Okay, and that's that answer. So when you approach problems, you need to read them and ask yourself, does order matter? All right, so you're burning a demo CD for your band. Your band has 12 songs stored on your computer. However, you only want to put 4 of them on the demo CD. So in how many orders can you burn 4 of the 12 songs on the CD? So it's telling us order. So this is a permutation. So we have how many? Remember, it's have permutation want. We have 12 songs. We want to put permutation, 4 of them in order. You can do this in your calculator. You could also use the placeholder system. There are 4 songs that we want to put on the CD. There are 12 choices for the first, then 11, then 10, then 9. And when you multiply those together, you should come up with an answer of, what I have, 11,880. This or this Doesn't matter. It's just however your brain operates. Okay. So number 7, how many combinations of 4 pineapples are there taken 2 at a time? So first, it uses the word combination, right? But second, it's just like groups, okay? Combinations, a lot of times there's groups, all right? Or a committee. Like I just want a committee of 2 guys, 2 girls. It doesn't matter which guy or girl I picked first, right? They're just combinations. So how many combinations of 4 pineapples are there taken 2 at a time? You're going to have 4 combination 2. It's how many you have, combination how many you want. It's going to take care of the formula for you. This one you have to do in the calculator. So you're going to go menu, probability, number 3, combinations. All right. And you're going to do 4, 2, press enter. And it gives you an answer of 6. Okay. It takes care of this extra r factorial in the bottom here, which is why you can't use these for combinations. These ideas are only able to be used for permutations. So, number 8, if there are 8 books, in how many ways can 3 of them be arranged on a shelf? So if we have 8 and we want to arrange them on a shelf, that's putting them in order on a shelf. So that's permutation. We want to pick 3. So you could use your placeholders, 3 spots, 8 choices for the first, 7 choices for the next, 6 choices here. And you would get, what do we get? I don't even know. 8 times 7 times 6. 336. Or you could do 8 permutation 3 in your calculator. It will also give you 336. Okay. The shop owner has 12 bikes and wants to put 5 in a window. How many different groups of 5 can be made? I just want groups of 5. It doesn't matter first, second, third. I just want 5 bikes. So this is a combination. So I'm going to have 12 combination 5. And 12 combination 5 should come up as 792 when you put it in your calculator. I'm expecting to see this as your work, all right? Not just an answer. You need the work and the answer, all right? So 3 more problems that are all kind of the same. In a club, there are 7 women and 5 men. A committee of 3 women and 2 men is to be chosen. How many different possibilities are there? Notice it's not probability, it's possibility. So with this, you can have women and men. So if you have 2, you're going to do a combination for women and means multiply a combination for men. Women, there are 7 women. Remember, it's how many you have, combination how many you want. Women, there are 7 women. And we want 3. And there are 5 men. We want 2. Put this in your calculator, you get 35. Put this in your calculator, you get 10. So our answer is 350. Okay. Well, what if we change? If the same club from above, so our halves are the same, we still have women and we still have men. And we still have 7 women, and we still have 5 men, but this time we want to change it to be 3 men and 2 women. So we want 3 men, and we want 2 women. Last time it was 3 women, 2 men. Now it's 3 men, 2 women, and means multiply. 7C2 is 21. 5C3 is 10, and we would get 210. All right, so number 12 is a challenge. From the same club above, how many different 5-person committees can be formed with 3 women, 2 men, or 3 men, 2 women? So 3 women, 2 men is this problem. 3 women, 2 men. This is number 10. And then 3 men, 2 women is this problem. Number 11. Or means add. So our answer for number 10, we had 7C3 times 5C2, which came up to be 350. number 11, we had 7C2 times 5C3, and we got 210. Or means add. 350 plus 210 comes up as 560 ways. Okay, I know this was a lot of content. Good job. Way to take amazing notes. Make sure you make notes also of what questions you have so you can ask them as you're working. Okay, good job today.